The last law that we need to investigate is Avogadro's law in 1811. And this law is describing how volume changes when the number of moles change. So what would be my two variables that would be constant here? Well, it would be pressure and temperature. Okay, keeping with the theme, let's watch an explanation video.
Let's take a look at limiting reactants. Each of these flasks has 190 milliliters of 1 molar acetic acid. How many moles of acetic acid is that? These balloons have differing amounts of sodium bicarbonate, 4 grams, 8 grams, 16 grams, and 32 grams. How many moles of sodium bicarbonate are in each of these balloons? Can you determine the limiting reactant for each flask? Acetic acid and sodium bicarbonate react in a 1-to-1 ratio to produce carbon dioxide. Let's do each of these reactions and compare the sizes of the balloons. First, 4 grams. Next, 8 grams. $16 grams. And 32 grams. In these two flasks, the sodium bicarbonate was the limiting reactant, so it could only produce as much CO2 as it had sodium bicarbonate. This flask, the 16-gram flask, is the stoichiometric ratio, so this is a perfect 1-to-1 ratio. In this flask, the acetic acid was the limiting reactant. These should be pretty much the same because they had the same amount of acetic acid, so that's all that could react.
Okay, so I like that video because it goes into a topic that we're going to be talking about next day, which is stoichiometry and limiting reagents. But all you had to get from this is that when we increase the number of moles of sodium bicarbonate that was added, the volume also increased. So this is the relationship between number of moles and volume. When the number of moles increases, the volume increases. When the number of moles decreases, the volume decreases. This is a directly proportional relationship between volume and number of moles. So just like 3 out of the 4 have been, we've got volume is directly proportional to number of moles, so V equals K N. The N got dropped there somehow. And then K is equal to V over N. And this is going to be at a constant temperature and pressure. So again, we can set up V1 over N1 equals V2 over N2. And again, it's ideal if your volume is both in liters, although as long as your volume are in the same units, it's fine, especially if what you're solving for is the number of moles. All right, let's try a question. So this says a scale model of a blimp rises when it is filled with helium to a volume of 55 decimeters cubed. When 1.0 moles of helium is added to the blimp, the volume is 26.2 decimeters cubed. How many grams of helium will make it rise? So this is actually my V2, and I want to know my N2. Okay, but we actually want to convert that to mass. But what we'll have is we've got that the V1 is 26.2 decimeters cubed when the N1 is 1.10. Distracted by somebody at the door. N1 is 1.10. So we're going to be solving for N2, and then we're going to be converting that to mass. So we're going to set up V1 over N1 is equal to V2 over N2. And like always, you can rearrange the equation first, or you can put numbers into it. So for me, if I was going to solve for N2, I would multiply both sides by N2. And then I would end up with wanting the N2 by itself, so that I would multiply by the N1 and divide by the V1 to both sides. And you would end up with N2 is equal to V2N1 all over V1. But again, if that feels just horrible, you put in the values with numbers into this equation, and then you do what you can, and then you'll divide and multiply as needed. So if I was to do it with this rearranged equation, I would get, now I'm going to keep my volume in decimeters cubed, just to reiterate that if you wanted to change it, we do know that 1 decimeter cubed is equal to 1 liter anyway. So we could just say that this is 55 liters and that this is 26.2 liters. So we're going to put in the V2 as 55. We're going to put in the N1 as 1.10, and we're going to put in the V1 as 26.2. And we would have done the same thing up here too, where we would have put in V1 as 26.2, N1 as 1.10, V2 as 55, and then N2 down here. And then you would just divide these answers out, multiply by N2, and then divide down, and you would end up with N2 is equal to 55 divided by the answer of this. So either way that you're going to plug this into your calculator, you get 55 times 1.1 divided by 26.2. We would end up with, how many sig figs are we talking about? 2. So I'm going to end up with 2.3 moles of helium, which is not diatomic, but they want to know mass. So next lesson is going to be all about stoichiometry, so let's practice this. If I want to go from moles to mass, I know that 1 mole of helium weighs what? So we're going to go over here. We're going to go to the first page of this formula sheet, or we can go to the alphabetized list, but I know where helium is. Helium is 4.003. So I'm going to put in 4.003 grams. And I'm going to take that answer. So this actually wasn't a final answer. So I'm going to go dot, dot, dot. So I'm going to take that answer. I'm going to multiply by 4.003. And I end up with 9.2 grams of helium. And I think that's the only example. Perfect. Awesome.